Welcome everybody, it's Mrs. Hofferberth. Let's talk about some of the basics of light. Light can be thought of as a wave, and when we draw a wave, we usually represent it something like this. When we look at a wave, we see this repeating pattern. We can talk about something called the wavelength. A wavelength is the distance between one point and the next time that that point repeats itself. So for example, the distance between two crests, or the distance between two troughs, or honestly any 2 points that are identical on the wave. So that's your wavelength. The symbol for a wavelength is given the Greek letter lambda. It looks like an upside down Y. And since wavelength is a distance, its units are going to be meters, or some version thereof. While the basic unit for wavelength is meters, when you start talking about the wavelength of visible light, the wavelength is really tiny. And so what we'll often do is use a unit called nanometers instead of meters. And 1 nanometer is 1 × 10⁻⁹ meters. You will find as we go on throughout the course of this video and the next video that we're going to have to convert back and forth between meters and nanometers depending on what the situation is. And this is just a conversion like you've done in this class earlier this year. So there's nothing special about this particular conversion. You'll just set up either a proportion or a dimensional analysis problem, but we can convert back and forth. So wavelength, units of meters, or for visible light, often nanometers. So that's one thing we should know about this wave. Looking at it further, we can also talk about the amplitude of the wave. The amplitude is the distance from the midline of our wave to either the crest or the trough, that maximum distance. Amplitude is another important feature of our wave. In terms of a classical physics standpoint, it was thought of as the intensity of the light, being the amplitude of that light. The last characteristic of a wave we need to talk about is frequency. Frequency is how many times per second the cycle repeats itself. So for example, a low frequency wave repeats itself slowly. On the contrary, a high frequency wave repeats itself rather rapidly. The unit for frequency is cycles per second, or as it's more commonly written, cycles per second is given the name hertz, which is abbreviated as Hz for that unit. It's worth noting that a low frequency wave will have a long wavelength and a high frequency wave will have a short wavelength. Just with the nature of the way that repetition works, you end up with a shorter wavelength the higher the frequency is. Amplitude is independent of frequency and wavelength and can be either large or small depending on the particular wave you're looking at. When we think of light, we usually think of the light that we can see, visible light. But it turns out that visible light is only one tiny slice of what is called the electromagnetic spectrum. These are fundamentally the same kind of wave, but with different frequencies and wavelengths. And because they have different frequencies and wavelengths, they behave differently and interact with our world differently. So if we look down below, you'll see the electromagnetic spectrum. There are radio waves, microwaves, infrared light, visible light, ultraviolet light, X-rays, and gamma rays. These are all fundamentally the same thing. They are a wave that consists of an electric field and a magnetic field. That's why they're called electromagnetic. And that electric and magnetic field that makes up the light is oscillating, is changing at different frequencies. And it's that different frequency that gives rise to the different types of light that we see as part of our electromagnetic spectrum. The lower frequency light is the radio waves, and the higher frequency light are your gamma rays. Because wavelength and frequency are opposite of one another, they are inversely related, the low frequency radio waves have a very long wavelength, and the high frequency gamma rays have a very short wavelength. We'll investigate these relationships in more detail in a future video and in class, but it's important to know that the low frequency, long wavelength light, that has very low energy. Whereas the high frequency, short wavelength light, though that light has a very high amount of energy. And this is why parts of the electromagnetic spectrum, like ultraviolet light associated with sunburns, X-rays, and gamma rays, these are much more damaging because the light has more energy in it. And so these are things we tend to try to avoid, whereas things like radio waves, which are all around us, are not particularly damaging. They have very low energy. So I've said that light is a wave, and that's true. But light is also a particle. Light is both. It is both a wave and a particle. And this really strange fact is known as the wave-particle duality of light. The fact that light behaves as a wave, we see that all the time with the way light bends and moves around corners. Light's particle nature was very clearly demonstrated in something called the photoelectric effect, which is an experiment. And the explanation of that experiment, which we're going to talk about the experiment in class, the explanation of that experiment with ideas from a gentleman by the name of Planck was actually carried out by someone you know, by Albert Einstein. And this is actually what earned him his Nobel Prize. Let's take a closer look at this idea that light is a particle. So a particle of light is called a photon. And this photon of light is like a little tiny packet of light energy. And it's these little tiny packets of light energy, when we're thinking about light as acting as a particle, that are actually hitting materials and interacting with them. So light can be thought of as a wave, and we can talk about wavelength, frequency, and amplitude of that wave. And the visible light that we see is a tiny sliver of all the different possible wavelengths of electromagnetic radiation that make up the electromagnetic spectrum. However, light is also a particle, and so there are photons of light, little packets of light that exist and that will interact with the world around them.